Hello, welcome to this C# support video. This is the 6th in the series on cybersecurity, where we're looking at different types of hashes. So in the previous challenge, we were just looking at SHA-256, which has 256 bits in the hash. In this challenge, you need to be able to generate either an MD5, which is less secure, which has more collisions, as in there's more chance of a random input generating the same hash as the actual password that originally generated the hash, or there are some algorithms that are more secure because they use more bits, and that means that there's less chance that a collision will occur, as in two different inputs will generate the same output hash. Still possible, it's just less likely. So there's a couple of different ways of approaching this. You've been given a enum which allows you to tell the difference between three different types of hashes. We need to create a static function. So public static, it returns a string, so we'll put a string in here. The name is generate hash, and it's going to need two parameters, a string and a hash type. So let's call the string input and the hash type. And it should return a string, so we'll have a hash and then we'll just return that hash. That should get rid of all of the syntax errors, but obviously it doesn't do what it's supposed to do yet, because we expect the MD5 hash of hello to be this, and we're just returning an empty string. So if we go back to the same example that we used before for SHA-256, in fact, maybe let's search for MD5 C#, you'll find a similar class that we can use, and are there any examples in here? Compute hash for an array of bytes should be an example here, and it looks very similar to what we had before. In fact, this is an example for SHA-256 rather than MD5, but we'll do something very similar to that. Can we pop this over there and this over here so we can see both at the same time? That would be helpful. So let's just start with an SHA-256 because that's what we've done already. Let's say SHA-256.create. We make an object and we store it. Hasher. Then we can use our hashing object to, is it get hash? Interesting. No, that's their built-in function. How have they done it? That's the one that we need. Compute hash. So that will return an array of bytes. What shall we store it as? Bytes. There we go. And it needs some data to be able to know what to compute. Now, last time we used ASCII. This time it's using UTF. It's fine to use ASCII because we're just having characters that can be encoded in ASCII. So let's see, encoding.ascii.get bytes. So we're getting an array of bytes from this input string. We're computing a hash and storing that that array of bytes here. What we now need to do is convert that array of bytes into a string. So we'll use a for loop again for int I equals 0, I is less than the length of our array. And for each byte, we want to add on to hash. And what do we want to do? We'll add on a string which is going to be in hexadecimal, 2 characters, and it will be bytes, at position I, because we're iterating through each byte in this array here. So this will only work if it's SHA-256. So we could have an if statement to say if it's SHA-256 do this, if it's MD5 do that, if it's SHA-512 do that, and just copy and paste this for each one. That's possible. What we'll do instead is use a switch statement, which is just like lots of if statements. So we'll say different things depending on what this value is. And we'll say if it is a hash type.md5, I want to do something. If it's a hash type.sha256, I want to do something else. The break just stops it from overflowing into the next possible case. And then we want the last one. There we go. So here, rather than copy and paste this each time, which is what we could do, we could look at this class and see that it's actually where is the class itself? Where does it say? Oh, this is just a hash algorithm. So hash algorithm is the superclass, the parent class, and SHA256 is a child class, the subclass. So we could just say hash algorithm and then use polymorphism to create a different one each time. So we pop that up here and then say if it's MD5, we can say create an MD5 hashing algorithm. If it's SHA256, we can make an SHA256 hashing algorithm, and if it's 512, presumably, we can just make a 512-bit hashing algorithm, and then regardless of which one we've got, pop this full screen again, the algorithm for actually making it is the same. They all share the same name of method, which is compute hash, and they all return the same type of data, an array of bytes. So we can just calculate the hexadecimal representation of that hash here, and that should work. Hopefully, probably won't, but we'll see. Oh dear. Where's this line 21? It's because I've got base instead of case. Well done if you spotted that while I was typing it. Use of unassigned local variable hasher. Well, it should only ever be these, but I suppose to get rid of that error, we could just say, if it's not any of those, then set it to MD5. Let's hope for the best. Excellent. So we're trying to hash hello with MD5 or SHA256 or SHA512, and then we should have 20 random inputs, and it seems to generate the correct hashes for each of them. Brilliant.